What if everything we thought we knew about ancient technology was wrong? In 1901, divers exploring a shipwreck in the Aegean Sea made a baffling discovery. At first, it looked like nothing more than a lump of corroded metal, but it would go on to rewrite history. Inside were intricate gears and detailed astronomical calculations, proof of a machine 2,000 years ahead of its time. Was this an ancient computer, lost technology, or something even stranger? Get ready for a mystery that's baffled scientists for over a century. In today's episode of The Infographic Show, scientists found a 2,000-year-old ancient computer that shouldn't exist. And make sure to hit that subscribe button for more videos just like this. The dawn of the 20th century brought great promise, but Captain Dimitrios Kontos wasn't chasing progress, he was chasing sponges. A seasoned fisherman, Kontos led a team of divers in search of the valuable sea creatures prized for human use. The waters off Antikythera Island, tucked into the far reaches of the Greek Isles, were rich fishing grounds. But what they found that day wasn't what anyone had expected. As his men descended, they discovered a massive shipwreck lying deep beneath the waves. And it was old. So old, in fact, that it became a national priority. The Hellenic Royal Navy was dispatched to the site, launching a full-scale recovery operation, and soon the story of the doomed vessels began to surface. It was a Roman-era ship, likely sunk in the second quarter of the 2nd century BCE, and like many ships of its time, it carried treasure, statues, coins, and artifacts that marked it as one of the most significant archaeological discoveries in decades. But the most significant find would slip under the radar for years. Many of the items pulled from the wreck were badly corroded after centuries in the sea, and at first it just seemed to be lumps of debris. But archaeologists knew that there could be anything buried in those lumps, and so mass quantities of debris were sent to the National Museum of Archaeology in Athens, where teams began the painstaking work of cleaning and analyzing each piece. A preliminary investigation on one such piece, retrieved in 1901, found a mass of corroded bronze and wood. The bronze had already begun warping after exposure to the air, making it difficult to study, so it sat in storage for 2 years, waiting for someone to realize what it really was. And once it was given a closer look, it would become the most important piece yet. When archaeologist Valerios Steas finally examined the strange lump, he made a discovery that stunned the academic world. Beneath the corrosion, he spotted something impossible: a gear. This wasn't just a random hunk of metal, it was a part of a machine, one far more complicated than anyone thought ancient Greece was capable of. The discovery soon got the attention of scientists and politicians, and they came from countries around the world to look at it and formulate theories. The first theory was that it might have been an astronomical clock, used to track the movement of the stars and the planets. But it was too complex for that, and believed to have been built too early. German scientist Albert Rehm soon made his way over and proposed it to be a more complex astronomical calculator. There were many theories, but relatively little evidence. The device was in pieces and heavily damaged, so the people of the early 1900s had few ways to investigate and discover its purpose. Investigations flagged for a while, and the pieces were carefully preserved and sent back into storage. But the 20th century was a rocket ship of progress in terms of science, literally in some cases, and it wouldn't be too long before someone else became interested. Among them was a Yale University professor, Derek J. de Sola Price, who began his research into the device in 1951, and it would become his life's work. At first, his work was mostly theoretical, but by 1971 he was teaming up with Greek nuclear physicist Charalampos Karakalos to make gamma-ray images of the many fragments that had been discovered. Would it be possible to truly piece together such a complex device from fragments? Not in the physical world. The fragments were so corroded that there was no way they would ever work again, and many were likely completely lost. But they gained enough information that they could begin sketching out the designs of what the machine could have looked like, and more importantly, what it could have done. And they used a word that no one would expect to be associated with ancient Greece: computer. No, the ancient Greeks weren't typing up memos on Microsoft Parchment, but the device you're watching the infographic show on had to start somewhere. The earliest computers weren't digital but analog. They were machines that used physical mechanisms like gears, cranks, or even flowing water to model real-world systems. And based on the fragments recovered, this was likely the largest device of its kind. Which raises the question, what was it for? The recovery of the mechanism, now known as the Antikythera mechanism for its discovery location, continued for a long time, and it still continues today. The shipwreck still lies at the bottom of the Mediterranean, with periodic missions still yielding ancient treasures. While artifacts are a bonus, the remnants of the machine are the grand prize. So far, a total of 82 unique fragments that belong to the device have been recovered, with scientists continuing to work to piece it all together. Some are more impressive than others. but together they paint a picture of a device that sounds like it came out of science fiction. While the device came out of the ocean in one massive encrusted piece, it wasn't treated with any special care, and it proceeded to fragment further soon after, creating a massive puzzle. The bulk of the known mechanism is contained in Fragment 1, which features a massive B1 gear with several smaller gears behind it. The device also contains several connecting trains and part of a manual crank that would have been used to manipulate the device. All of the gears are damaged, but enough of the structure remains to reverse engineer how the components worked together. But it doesn't just work, it speaks. The fragment contains key inscriptions, including what's known as the Saros Spiral, a depiction of the sky's properties during an 18-year period. This period, technically 18 years, 11 days, and 8 hours, was used to predict eclipses of the sun and moon. This was the first piece of evidence that the machine was definitely used to predict the movement of the skies. In other words, it was likely an essential tool for navigation, perfect for a crew on a seafaring mission. And considering that it was discovered at the bottom of the sea, that tracks. And there would be further clues in the other fragments. The second fragment, roughly a third of the size of the first, contains fragments of what's believed to be an inscription of the Metonic cycle, a 19-year astronomical cycle that can be used to predict the phases of the moon. While it only has one gear, this fragment is much more significant in terms of what it shows about the function. A third, slightly larger fragment contained parts of the front dial face. Inscriptions on this segment reference the calendar, the zodiac, and a dial believed to track lunar phases. It became clear that this wasn't a single-purpose machine. It was a multi-function astronomical guide, crafted centuries ahead of its time. From there, deciphering it became harder and harder. The much smaller fourth fragment holds at least one unknown gear, possibly designed to track Jupiter's position in the sky. Fragments 5 and 6 include inscriptions from what's left of the Saros Spiral. The sixth fragment is also significant for containing pieces of the device's wooden housing, the first clue to the construction outside of the core mechanism. The final fragment is a collection of shards that broke off of the third segment and are being kept for safekeeping. While many smaller pieces appear insignificant, scientists continue to explore them for hints as to how the device worked. And so this device has become the world's most significant jigsaw puzzle. Even the smallest piece has the potential to contain inscriptions providing further clues. While there is no putting the machine all back together, there are plenty of modern ways to advance the cause. One of the smallest fragments is believed to contain references to the Callippic cycle, a 76-year period that would predict the tropical year and synodic month, both of which could be critical in helping ancient seafarers predict the weather. Other fragments have inscriptions on them, but the scientists haven't been able to make heads or tails of them yet. But that hasn't stopped them from trying. There's been around 120 years of research into the Antikythera mechanism so far, and while no one has been able to conclusively piece it all together, they have some pretty good theories. It's believed to be an orrery, a device that predicts the movement of the solar system. While most today are models that simulate the movement, size, and speed of the planets, this one is likely designed to provide a general map. There is one major flaw in its design, by today's standards anyway. At the time, the geocentric model of space was universally accepted, meaning that the device would have predicted how the sun, moons, and planets all revolve around the Earth. So its view of the cosmos was, well, just a bit off. But that doesn't mean that there isn't a lot to learn from it. Multiple scientists have developed what they believe to be full working models of the device. While this is largely guesswork, they have created machines that fulfill the functions that the clues point to. And it is impressive. A clockwork mechanism that has many functions relating to the skies. The front of the machine features a fixed ring dial marked with 12 signs of the zodiac, which is believed to represent 12 constellations. A second rotating dial uses the months and the days of the Egyptian calendar of the era, with those names translated into the Greek alphabet. When you rotate the Egyptian calendar ring to the current zodiac sign by turning a hand crank, it's possible to keep track of the date. However, the calendar didn't account for leap days, so it's not ideal for planning your birthday. But that is just a fragment of what this device was used for. The device was packed with an intricate network of gears, each driving dials that tracked the sun and moon's positions, lunar phases, eclipse predictions, and various calendar cycles. Some researchers believe it might have even included indicators for visible planets, supported by a fragment referencing Jupiter. But this meant that unlike today's computers, the user had to be very involved in making sure everything was aligned properly before turning the crank. Only then could the device calculate the data points in perfect unison. In 2008, researchers discovered the Antikythera mechanism did more than predict lunar calendars and solar eclipses. It also tracked major athletic events, similar to the ancient Olympiad. Inscriptions matched Greek month names and indicated a 4-year cycle, aligned with known locations and dates of historic games. The device wasn't only the key to guiding people on the seas, it was the key to getting them back home in time for the must-see event of the year. The exterior was complex, and inside it was even more so. The device was housed in a wooden casing with front and back doors, each likely covered in inscriptions. Only fragments of these doors remain, but what is left contains details on the lunar and solar cycles. But what was inside was far and away the most complex device ever seen in this era. It's believed to have had at least 30 gears in total. Early researchers doubted that it could be real, but deeper studies of ancient Greek science proved otherwise. Some experts even believe that there were other functions, like indicators for all 5 known planets at the time, but evidence of them has been lost due to damage. And that has left scientists with one big challenge: to put it all together. Assembling the Antikythera mechanism is a near impossible task for several reasons. First, the mechanism itself is so seriously damaged and corroded that nothing can be done with the existing fragments besides glean information. Additionally, much of the machine is lost to the sea, so this is the equivalent of trying to put together a jigsaw puzzle after your little brother ate 5 of the pieces. But that hasn't stopped the scientists, with de Sola Price building the first simple model in the 1970s. But salvage missions have continued since then, and more information was discovered which led to much more complex models. And one British scientist believed that he might have cracked the code. Michael T. Wright was a curator of mechanical engineering at Imperial College in London, and in the 1990s he got his hands on this ancient Greek machine. He and his collaborators were able to create a series of complex X-rays of the device to simulate the device in 3D, which proved that the previous models had critical flaws. But he wasn't done yet. He wanted to build a working model, and he believed that there was far more to it than the original designs. His model filled in many of the blanks left by the damage, with mechanisms that reflected the placement of the planets in the sky, as well as the true sun. These additional pointers created a system that would be far more complex than any other device ever found from the period. A trio of scientists in 2010 published their own rejoinder to Wright. They noted the off-center spacing on the front dial face, and they believed this indicated an off-center sun indicator. Instead of adding separate indicators for each planet, their model added simple dials that would reduce the forces and complexities needed to run Wright's proposal. It was far simpler, but required more guesswork about where things were placed. Other scientists would follow, each with their own theory about where certain indicators were placed. This just proved how hard this device was to figure out, and now it was time to put it all to the test. All these models were designed to be functioning replicas, and we could now measure their effectiveness through countless other advanced methods. It was common to find inaccuracies in the tests, but it's not clear if this was due to flaws in the design of the models or flaws in the original machine. After all, it is rare for anything to work perfectly its first day out, and countless devices have been released to the public with bugs. It's possible, even likely, that the Antikythera mechanism was a stunning, groundbreaking piece of ancient technology that may not have really worked all that well. And that's led many people to search for answers in other ways. As much research as we've done into the Antikythera mechanism, we still have a lot more questions than answers. The device's very existence is a puzzle, and there is still little evidence of any other device near this level of sophistication existing in ancient Greece. However, it is possible that other examples did exist, but they simply didn't survive. The odds of this device making it to the present day are astronomical, and it certainly didn't arrive in good shape. Other models might have been more seriously damaged and no trace was found, while other land-based models might have worn out and been melted down for valuable scrap. And that has led many people to turn to the written word instead. Is there any evidence of complex astronomical devices existing elsewhere in ancient Greece or other civilizations? Well, yes and no. Mentions of devices that could resemble the Antikythera mechanism have shown up in literature, but these ancient texts are often hard to determine whether it's fact or fiction. Cicero's De Republica, a philosophical text from close to the same era, mentions machines that could be used to predict the movements of the sun, moon, and planets. Later times in the Byzantine Empire, it was known for its unique mechanical clocks, and the 11th century saw Chinese polymath Su Song design a massive mechanical clock tower that predicted the movement of stars and planets. But where did it all begin? For many people, there is only one suspect. Who is the greatest inventor of all time? If you said Edison, Tesla, or Da Vinci, you might want to go back further. Few did more with less than the Greek mathematician, engineer, and astronomer Archimedes, who is believed to have lived from around 287 to 212 BCE. Based in Syracuse, few details of his life are known today. But boy oh boy did he leave behind a lot of records. His work in math calculations is the foundation of modern mathematics, which might leave a lot of schoolboys cursing his name. But his most significant contribution is his physical inventions, which pushed the bounds of what was possible at the time. Could he be the father of the Antikythera mechanism? That depends on what you mean by father. It's very unlikely that he built it, as the device has been dated to roughly the 1st century BCE, close to 100 years after Archimedes died. But his work on machinery might have been key to unlocking its secrets. He worked extensively with systems of gears, pulleys, and screws. Many of his inventions were never actually built, including a series of designs for massive defense machines that would protect Syracuse from invasion. But if a machine of this complexity existed, it might have come from his brain, especially since revolutionizing math and construction wasn't enough for this man. He is also known for developing some of the earliest astronomical calculations, including the size of the universe and the diameter of the sun. There are references in his text to having built one of the first planetariums off of his dimensional calculations, which would be a key part of the work behind the Antikythera mechanism. While he was eventually killed by a Roman soldier during an invasion, many of his texts survived and could have been passed on to other scientists. They would have been able to expand on his work and turn it into reality aboard that famous ship. The Antikythera mechanism doesn't just make us wonder about Archimedes, it completely changes how we see the ancient world. Greek tech wasn't just ahead of its time, it was mind-blowing. They created automatic temple doors, intricate water clocks, and even primitive steam engines, tools that wouldn't reappear for another 1,500 years. Science fiction writer Arthur C. Clarke once said that if the Greeks had really understood the potential of what they were creating, they could have made it to the moon in 300 years. And by now, we might be exploring other star systems. The Antikythera mechanism, with its complex gears, precise astronomical tracking, and surprisingly compact design, feels too advanced for its time. Some historians even believe that if Greek innovation hadn't been cut short, the industrial age could have started centuries earlier. But in the end, the Antikythera mechanism is still wrapped up in mystery, and that is part of what makes it so fascinating. It's one of the greatest puzzles in scientific history, and it continues to attract salvagers, scientists, and historians to see if they can bring understanding of the device one step closer to reality. And with current technology, methods like 3D printing have been able to fill in some of the potential gaps like never before. And that means that you can't just read about the Antikythera mechanism, you can see it. The remnants of the exhibit itself were on display at the National Archaeological Museum in Athens in 2012, and it was accompanied by recreations from some of the top scientists who worked on it. While the exhibit was only temporary, today you can see recreations at the American Computer Museum in Montana, where the device is celebrated as one of the earliest examples of computing power. There are also displays in Greek museums and beyond, and the device was even recreated in Lego in 2010. The surest sign yet that something has captured the public's imagination. It's even popped up in Hollywood, and that means that more and more minds are focused on it each year. Like a jigsaw with countless pieces, the Antikythera mechanism continues to taunt some of the most brilliant minds in the world. We know enough to understand its general function and its construction, but key pieces are still missing, pieces that may never be found. How did it fully work? Who created and built it? Was this its first voyage, or was it a key part of Greek and Roman seafaring? And it's not giving up all its secrets easily, so investigations and salvage missions are likely to continue. It's been 2,000 years, so what's a few more decades? The ancient Greeks weren't the only ones ahead of their time when it came to tech. Watch 20 insane ancient inventions that will blow your mind to see just how advanced other ancient civilizations really were, or click this video instead.